Hello everyone, welcome back to another video. In this video, we'll be solving the question merge k sorted lists. Now, if you look at the objective of the question, it says that you are given a list of lists where each of the lists is sorted, and you're required to complete the body of the function merge k sorted lists. The function is expected to merge k sorted lists to create one sorted list, right? So much like how we did the function merge two sorted lists, if you remember, we had two sorted lists and we created one sorted list using those two lists, right? So in this case, we would have k number of lists, right? So for example, let's suppose we have lists 1, 2, 3, and let's suppose I have 4, 7, 8. Let's suppose I have 5 and 6 and 9, and then I have, let's suppose, 8 and 9 and 12 and 13 over here. Suppose I have 7 over here, right? So let's suppose I have these 4 lists, and in this case the value of k would be 4, right? So we have 4 lists, that means k is equal to 4. What I want is I want to combine all of these lists such that I would create one single list and that entire list would be sorted, right? So what can I do? I can have 1, 2, 3, and then 4 from here, then 5, and then 6, and then 7, and then we have 2 8s, then 2 9s, and then what we have two 7s actually. Then we have what? We have 12 and 13, right? So this is the expected output, right? This is the expected output. We need to create a list using all of these lists such that the last list that we create after combining all of these lists is also sorted, right? So I would want you to attempt this question on your own. A slight hint for this would be that this question is going to use our priority queue, and try relating this problem with the previous merge to sorted list that we did, right? If you get stuck somewhere, take help of this video or the article, right? Moving on with the solution of this question, right? So what I said was, what we can do is we can approach this question just the way we approach the question merge to sorted lists. So if you don't know the solution of merge to sorted lists, I would highly recommend that you do that first, right? Only then you would be entirely able to get the insight of this question as well. So what we did was, in merge to sorted lists, we compared the first element in both of the lists, and whichever one was the smallest, we added that to our final list, and then we put the pointer in the next part, right? So for example, if I had to take example, let's suppose I have list 1, 2, 5, 7, 8. And I have another list which is 3, 4, 6, 9, 10, 11. Right? What I would do is I would have two pointers, one pointing to this, right? One pointing to this list and one pointing to this list, right? And then I would have another list which would be my final list, and what I would do is I would check which one of these are smaller, right? So in this case, as one is smaller, I would fill one over here and then I would move one in front, so this would get over here, right? Again, I would compare. As 2 is smaller, I would put 2 over here, and then I would move I one step ahead, right? Now I would compare. Now 3 is smaller, so I would add 3 over here and point J to the next element, right? Now if I compare again, I would have 4 over here and J goes forward again, right? Again, if I compare, I would get 5 over here and then I would go forward, right? Again, if I compare, I would have 6 over here, J would go forward, right? Again, if I compare, 7 is smaller, right? So we would have to add 7, I would go over here, right? Again, if we compare, 8 would come over here, and then I would point to nothing, right? I would get past the size of this array, right? So now what would happen? We would break out of the loop, and the remaining values in this array would be copy pasted, right? So we would copy the contents over here. So at the end, what we would get is a sorted and merged array, right? Sorted and merged array, right? This is what we did in order to merge two of sorted arrays, right? So what we can do in k arrays, right? K arrays. What can we do in k arrays? Over here we have those k arrays. Let's see what we can do in this case, right? What I'm saying is, if you observed it more carefully, what we did was we picked out the least value out of all of the pointers that we had, right? So if I have pointers for each of these array lists, so this is array list 1, this is, if I write more clearly, if this is my array list 1, this is my array list 2, this is my array list 3, and this is my array list 4, what I would have is 4 pointers, right? 4 pointers. Let's suppose this pointer is I1, this is I2, this is I3, and this is I4, right? And this could go to IK, right? But in this case, K is equal to 4, right? What we want to do is we want to find the minimum out of all of these three. So a way could be that we can iterate over all of these indices and we can find the minimum, right? That would be of the complexity O of n, right? But what I'm saying is, instead of looping over, what we can do is we can have all of these elements, inside a priority queue, right? We can have all of these elements inside a priority queue, right? And the priority queue will tell us what is the minimum element, right? So let's suppose I have a priority queue over here, right? I have a priority queue over here, and if this is the front of the priority queue, then if I feed all of these values, which are 1, 4, 5, and 8 over here, then priority queue would automatically take 1 from here and put it on the top, right? Now, if I tell my priority queue, let me know which one of these is the smallest, it would tell me, okay, this one is the smallest, right? So as soon as I get 1 over here, I would take that one and I would add it to a sorted array, right? So I would add one and I would move forward, right? I would move forward in the array list that had the minimum value. So I1 would be on 2 now, right? And this has been popped, right? So this has been popped. Now, if we think about it, now 4 of our values are 2, 4, 5, and 8. So there is 2, 4, 5, and 8. Again, 2 is the smallest. So we would have 2 at the top, right? Again, we would ask the priority queue, which is the minimum element. It would say 2, right? So we would get 2, we would fill 2 over here, and then we would push the iterator in front, right? So I1 gets to 3, right? Again, what would happen? This 2 would be popped. What we would have is 3 inside it. And again, it would check which one is the minimum, right? Which one has the least value. So it would say 3 has the least value, right? So again, my priority queue is saying 3, then I would have 3 over here, and then I would move the iterator one step ahead, right? So I1 goes to 7. Now, if we see, 3 has been popped, and what we are adding is 7, 4, 5, and 8. Right? Now, out of these all, what we have is 4 as the minimum, right? 4 becomes minimum, right? So if I ask my priority queue again, which one is the smallest, it would say 4. I would pop 4, put it over here, increase the value of the index to the next index, right? And then as I have popped 4, it would be removed and the new value, which is 7, will be pushed inside the priority queue, added inside the priority queue, right? Now again, which one is the minimum? 5, right? So 5 comes over here, right? Now if I pop 5, I would add 5 over here and I would push I3 forward, right? Another thing to notice is that whenever we are popping an element from a priority queue, we have to know which array list that particular element belonged to, right? If I'm popping 5 over here, I would need to know 5 belonged to array list of 3. So what we can do is we can push array lists inside our priority queue and we can let our priority queue know that what we want to compare is particular index in all of these priority queues. So array list of 1 would have I1, array list of 2 would have I2, and array list of 3 would have I3, and array list of 4 would have I4. And what we want our priority queue to do is to compare array list of 1 I1, array list of 2 I2, array list of 3 I3, and array list of 4 I4, compare them to each other and let us know which one of these is the smallest. Right? In that way, we would know the smallest item as well as the array list from where the element is coming from. Right? So if you look at it, we have 7, 7, 6, and 8. So 6 get pushed. Right? Now 6 would be pushed as, if I have to write the actual values, it would be something like this. 7 is nothing but array list of 1 at index of 1. Right? And currently the index of 1 is what? 0, 1, 2, 3. So index of 1 is 3. Right? So in array list of 1, any element that is at position 3. Right? This is what I1 means. So if I remove this, right, and if we talk about I2, right, I2 is 7. Right? So this 7 is nothing but array list of I2, and I2 is nothing but at the position 1. So array list of 2 at position 1. Right? And the 6 is nothing but array list of 3 at position 1. Right? And this 8 is nothing but array list of 4 at position 0. So now our priority queue will look at these array lists at this particular index, and it would compare all of these elements and it would tell me which one is the minimum. So if my I1 is over here, it would say, okay, out of all of these, the minimum, my I1 is at 7, right? Okay, over here. Right, so it would say that array list of 3 at position 1, which is the value 6, is the smallest out of all of these. Right? So what I would do is I would have this on top. So this would be on top. If I make this a little more bit bigger, what I would have over here is array list of 3 at position 1. Right? Then this would be popped, this would be removed, and what we would get as element is 6. And then what we can do is we can increase the value of 1 to 2 and push it again. So what we would have over here is array list of 3 for position 2. Right? And if I remove this, again, now what it says is my I3, right? The I3, which is pointing out array list of 3, has now moved to position number 2. So this is no more over here. This has moved to this place. Now out of all of these, I1 and I2 are the smallest ones. So let's suppose it pushed out. Let's suppose it pushed out this position, right? Array list of 2 at first position. Right? So this is the minimum now. If this is removed, I would add 7 over here, and then I would increase the index by 1. So array list of 2. Right? I hope you got the idea of what I'm trying to do. Right? So let's try to code this. Right? How can we code this now? To code this, I need to have an object which can store my array list as well as the current index in that array list, right? So that our priority queue knows what to compare, right? So for that reason, we would be making a pair class, right? So we would have public static class pair, right? And inside this pair class, what we would have is a array list of integer type, right? Let's call it AL and an index, right? And let's have a constructor for this. So array list of integer, and I would just pass array list at first, and I would initialize my index as 0. So array list, this dot array list equals to array list, and this dot index would be 0. So I'm not passing my index as a parameter because initially when I would be creating an object of any array list, I would want all of the pointers to point to the 0th element, right? So that's why I'm taking the default as 0 over here, right? I hope you understood this point. Okay, if I take there, okay, now what we have to do is create a priority queue, right? So priority queue, right? And this priority queue would be of type pair, right? it would hold my array list as well as the corresponding indexes, right? So let's call it PQ, new priority queue. And over here, now what do we want to do? We want to initialize our priority queue, right? So we want to add the pairs inside it, right? So to do that, what we would do is we have our input over here, which is a list of lists, right? We have to take each list out of this and we have to add it to our priority queue, right? So we can loop over the input, which is lists, and it would get us each and every list, right? So I'm using a for each loop for that purpose. And inside the priority queue, what I would add is a new pair of a particular list, right? So I hope it's clear. So over here we are initializing our priority queue, right? Next step is to iterate over the priority queue until the priority queue is empty, right? So priority queue size should not be equal to 0, right? And at each time what we are doing is we are removing an element from priority queue, right? So we are removing a pair from priority queue. So we would get a pair, let's call it current, and we would remove, right? So over here what we are doing is removing from priority queue, of course, right? So we would remove the element that has least value, right? So what we are going to do is we are going to just add that element to our RV array list. So this would be our resultant array list, right? And in this I would add what? Current dot array list. So the array list that we have just got from the pair dot get what? Current dot index, right? So from that particular array list at a particular index, I would have my least element, and that is the element that I would add with RV, right? Now that I have added, if we come back to our open board, what I did was I popped the entire pair, I added that element to my RV, this is my RV, right? And then what I did was I increased the index, right? I increased the index, right? So let's do this. How would I increase the index, right? So my index is at current.idx and I can just increment it by 1, right? This seems fine. This is what we were doing. And what we have to do is we have to just add this current back to the priority queue because we have removed this, right? We have removed this. So what we have to do is we have to add this back, right? So we have to add our current back to the priority queue. Now, there is a problem with this code. The problem is if let's suppose my I1 goes over here someday, right? My I1 becomes greater than the indexes that were offered by my array list. In that case, I won't have any element over here, right? And if I don't have any element, do I need a pair class for that, right? I don't, right? I don't need that instance in my priority queue. So what I can do is I can check if my index ever becomes greater than or equal to the size of the array list. That means its index goes out of bound. What I can do is I can not add the current pair inside the priority queue. Again, I would just leave it, right? So over here I can have a check that if my current dot index becomes greater than or equal to current dot array list dot size, right? And if that's the case, what I can do is I can not do anything, right? So if not, I want to add, right? And if it is, I don't want to do anything. So instead of this, what I can do is I can write a reactive code and I can have this inside it, right? So what this check is doing is basically telling me whether the array list that I have, the pair that I have has an index which is smaller than the size of the current array list or not, right? This is the check, right? I hope you understood this check, right? So now it seems fine. Now it seems perfect, right? At the end, we are just returning our RV. So out of this loop, we should get our RV. The only part that's missing in this question right now is how do we let our priority queue know at which particular, on the basis of which parameter do we want it to sort, or let us know the minimum value, right? What do I mean by that? I mean that whenever we had a priority queue before this, whenever we had a priority queue, that priority queue was of type integer, right? That priority queue was of type integer. But in this case, we have made a priority queue of type pair. Now, when we wanted a minimum value in an integer, a priority queue was very clear about it, right? Integers, it used to compare the integers, it used to give us the minimum value of the integer. But in this case, as we have a pair, if you look over here, our array list is our priority queue is storing array lists and their index. So I have to let my priority queue know on the basis of what it has to give me the least value, right? The minimum value. And that is the value at the index of each and every associated array list, right? So I have to let my priority queue know that it has to compare all of the elements, all of the pairs on the basis of elements at those particular indexes inside those array lists, right? So how do we do that? For this purpose, we are going to implement a comparable, right? We are going to implement a comparable. Okay, so if you're not clear about the concept of comparable that much, look at it. I'm just explaining it brief. If you want to learn it in more depth, you can move on to the video in which comparable are being explained along with heap, right? So comparable is implemented over pair class. And what we have to do is we have to just let them know that what it needs to compare. So we would write a compare to function, and this function would get a pair as a parameter, right? And what we have to return is this dot array list dot get this dot index, right? So in this array list at a particular index minus o dot array list dot get, right, o dot idx, right? So this says that in the particular array list at a particular index and in the other array list at the other index, you have to compare these two, and according to that you have to let me know the minimum value inside the priority queue, right? So now our code looks finished. Right? So we are returning RV at the end. So let's try to run this and see if it works, right? Let's try to catch some errors if there are any. So there is a compilation error and it says that we are expecting a opening bracket, right? So we are missing a opening bracket, which shouldn't be the case. Okay, so we are implementing, so it's implements, right? Instead of implement, it's implements, right? So if we run this again and it's accepting, right? So our code is working perfectly fine, there is no error. Let's submit it for all the test cases, right? Okay, so it's submitting, we are getting 10 out of 10, right? So I hope you got the concept, right? The code is much more simpler if you understand the concept of what we did, right? We added array lists and corresponding indexes in our priority queue, and then we told our priority queue that we have to compare on the basis of the elements, right? Elements that you get from that particular index, which is associated to each and every array lists, right? And for that purpose, we created a pair class and we implemented comparable over it. All right. So after that, what we did was we basically pushed all of our array lists, all of our arrays inside the pairs, right? And we pushed those pairs, we added those pairs to the priority queue, right? And that priority queue then gave us one by one the minimum value. And as soon as we got a minimum value, we put that minimum value in the RV, which is the resultant vector that we got, and then we incremented the pointer of that particular array list. And then we also had a check to see if our index is out of bounds or not, right? And then we repeated that process until unless our pair class was completely empty, and that would be when all of the indexes would reach size equivalent to size, right? That is when all of these elements would be processed, right? So I hope you got this. I will see you in the next video. See you. Bye bye.
Okay, so see, this is how we implement a priority queue using heap. If you like the video, please don't forget to share and subscribe, and I'll see you guys in the next video. Thank you.